Hey there, so this is a video on number 17 of the practice final for Math 160. So this question has to do with mean serum cholesterol, and you're given the mean and the standard deviation, and this is from a sample because it tells us that this simple random sample of 107 adults. So this is from, I'm just going to note this is from a sample, this information. And so the first question asks, what's the probability that the sample mean cholesterol is greater than 207? So the first thing I'm going to do is I am going to draw a picture. Okay, I'm going to draw the bell curve. We've got a sample that's greater than 30, so I know that this data is approximately normal. So I can draw a bell curve, and I'm going to put the mean in the middle of 199. And then in the question, it asked, what's the probability, okay, that the sample mean is greater than 207. So I'm going to draw a line to the right of 199 and label that 207 because 207 is greater than 199. So that's it tells me to put it to the right. And then I want to know the probability that the cholesterol is greater than that. So I'm going to shade everything to the right because greater is right. And then I'm asked to find the probability. So anytime you see probability or you're asked for a proportion or the area under the curve, you're going to use normal CDF in the calculator. And normal CDF, okay, asks for the left bound, which means the left-hand side of the curve. Let me just use a different color here. So the shaded region, this would be my left side. And then over here would be my right. So imagine that you're just kind of hugging that curve on either side. Where does it start and where does it end? Okay, that's going to be the right and the left. So we want a leftmost point, a rightmost point. We're going to do the mean and then the standard deviation. And if it's from a sample, which in this case it is, the standard deviation, we have to use a special formula for that. So it's not just standard deviation, it's standard deviation divided by the square root of n, just to adjust because the standard deviation in samples are slightly smaller than that of the population. So in this problem, my leftmost number of my curve is 207. My rightmost is way over here. I don't have a specific number. I just want to keep going as far right as I can. So I'm going to write 10 to the 99th power. That's a very large number. So it takes that curve as far right as we can. The mean is 199, and then the standard deviation is 39.8. I'm getting that from the problem, divided by the square root of the sample size, which is 107. Okay, so from this point, I'm going to go to my calculator, and I'm going to hit second vars, and I'm going to go down to the second option, normal CDF. And so for my lower number, I'm going to type in 207. My upper is 10 raised to the 99th power. My mean is 207. And my standard deviation is 398, or I'm sorry, not 398, 39.8. 39.8 divided by, whoops, too many 8s there. Delete that. 39.8 divided by the square root of 107. Okay. Oh, I gotta do it one more time. Hang on. 39.8 divided by the square root of 107. Okay, third time's a charm. And then I'm going to hit paste. And looks like we've got I hit it too many times, 0.49995 at the end there. And it says, let's see, does it tell us how to round? Oh, you know what? I must have cut that off. You'll just have to look at on Connect how it asks you to round, but your answer for this one should be approximately about 0.50 if we round to, well, really any decimal place should be 0.50. Okay, so for part B, I'm going to do this one here, and I'm just going to erase the information from the last problem. That's going to change. Okay. So for part B, B also asks for probability, so I'm going to do normal CDF for that one as well. I'm going to do the 199 in the middle for my mean, and then this for part B, it asks for between 187 and 193. So 187 is less than 199, and then 193 is also less than 199. So I'm going to do these over here on the left hand side, and then I want to know the probability of being between those two numbers. So in this case, my leftmost value, okay, this is going to be my left side of the curve, and this right here is going to be my right side of the curve. Okay, so those numbers are going to go in for normal CDF. I'm going to start at 187 and go to 193, and then the mean and standard deviation are going to be the same as the last problem, and it makes it kind of nice because then you don't have to type them in again. So I'm going to go second vars, unless you have an older calculator, you will have to type them in. So normal CDF, I'm going to do 187 and then 193, and then everything else stays the same, and I'm just going to hit enter. And then, okay, so you'll notice this one, we get an answer with an E-4 at the end. So let me write this all out and talk about what this means. So e to the -4th just means times 10 to the -4th power. And whenever you're multiplying by a really small number, and 10 to the -4th is a really small number, you're basically need to just move the decimal left however many spaces that the exponent tells you. So a -4 just basically means move the decimal 4 left. So I'm going to take my decimal and I'm going to go 1, 2, 3, 4, and I'm going to put zeros in the empty spaces. So if I round to, let's say, 1, 2, 3, 4 decimal places, it'd be approximately 0.0001 would be my answer for that one. Okay, and then last but not least, for part C, would it be unusual for the sample mean to be less than 194? Okay, so let me just erase this. Whenever a question asks about something being unusual or not, you have to compare the answer to 0.05. If the probability is less than 0.05, then it's unusual. So you say yes. So we have to find the probability and then see if it's less than 0.05. So I'm going to draw the curve again, put the mean in the middle. We're being asked, is it unusual to be less than 194? So I'm going to draw a line to the left of 199 and right 194. And it's asking about less than 194, so I'm going to shade everything to the left. Then I mark where my left and my rightmost values are on my curve. Okay, and then I'm going to plug that into the calculator. So my leftmost value, in this case, this curve is going all the way to the left, so I want a really, really large negative number. So I'm going to use -10 to the 99th power. So -10 to the 99th power is going to be my left bound, 194 is going to be my right, and then the mean and standard deviation stay the same. So I'm going to come over here to the calculator, second vars, whoops, let me go back, second vars, and down to number 2. And then I'm going to do -10 to the 99th power. Oh, and you know what? My other numbers erased from before. 194 is going to be my upper. 199 is the mean. And the standard deviation is 39.8 divided by the square root of 107. Whoops. Square root of 107. Okay. And then paste. Okay, so I get an answer of 0.096884. So the key here is let's compare that to 0.05. So that is going to be greater than 0.05, so we're going to say this is not unusual. All right, I hope that helps.